In the last video for Chapter 1, video number 5, we're going to talk about a couple different things again. We're going to start off with box plots, which are something that I'm sure you've done sometime in the past, except once upon a time they were called box and whisker plots, except now we just call them box plots. So just like we had stem plots, that they were called stem and leaf plots, we are simplifying our phrases here and just going with box plots. Okay, now box plots are made up of 5 values. You've got the minimum, Q1, which was our first quartile, which was basically the median of the first half of our data. The median, which we could also call Q2 if you would like. Q3, which was our third quartile, and the maximum value. And so those 5 numbers make up something that's called literally the 5-number summary. And we need those 5 numbers to make our box plot. Okay, and the easiest way to get those values is with our calculator. Okay, so I will discuss how to use your calculator, which commands you're going to need to use to get those 5-number summary values. Okay, and we can even look at a picture of a box plot in your calculator. So a modified box plot shows outliers as usually dots or asterisks or something beyond like the whiskers, if you will, the arms of your box plot. And the outlier rule that we talked about in the last video, that 1.5 IQR either below the first quartile or above the third quartile, will help us to determine if we really have any outliers. So right now in your notes, you have these 2 boxes for set 1 and set 2 data. What I did for set 1, notice it's in red, hopefully you're not colorblind, is that those are the last 12 um, runs scored in the past 12 games for the St. Louis Cardinals. Okay. And set 2 is for my Yankees. Those are the last 11 games. This kind of goes back to the All-Star game. That's why there's fewer games here for the Yankees than there are for the Cardinals. But notice that if you look at the values, hey, the Cardinals, they got some big values here. They scored 9 and 11 runs. And then they're mostly in the 0, 1, 2, 3, 4. The Yankees, they might have a 7 here, a couple 6s, a couple 5s, and then mostly some smaller numbers. So we're going to use these to determine if maybe there are any outliers and to kind of compare these 2 distributions to see what they kind of look like as box plots. So again, I promised you with your calculator. So if you take your calculator, turn it on, go to Stat Edit. So you go to your lists. And if you have numbers in your lists, because we're going to use list 1 and list 2. So if you have something in list 1, press the up button so that the L1 part is being highlighted. And then press clear. Don't press delete, because delete's going to get rid of the list. Press clear and then press enter. And that'll flush out all of those numbers at the same time. And then go down to the first entry and put in these 12 values for the Cardinals. Okay, just press 9, enter, 3, enter, etc., etc., till you get to the end. And then when you're done with those numbers, jump over to list 2. And if you have anything in list 2, again, put the highlight on L2, press clear, enter, don't press delete, and then put in the 11 values down here for the runs scored by the Yankees the past 11 games. Okay, so go ahead and do that. If you need to pause the video to plug all that stuff in, go ahead. So now I'm going to talk about how do we take these 2 sets of lists, or 2 sets of data, and have the calculator get the 5-number summary for us. Now, we can very easily see what the min and the max is going to be for both of these sets of data, right? The min for both are 0 and 0. The max for the Cardinals is 11. The max for the Yankees is 7. But the other 3 values, we'd actually have to do a little bit of thinking here. But thankfully, we have the calculator. So when you're done putting in the numbers, press second mode to do the quit function to take us back to the home screen. And then what I want you to do is press the stat button, then press over for calc, and then there's one var statistics. It's that very first option. Go ahead and press enter. And by default, the list, it has it as list 1, which is fine. Let's do the cardinal data first. So just well, for my calculator, it automatically pops up and says list 1. For yours, if you have an 83, for instance, or maybe you have an 84 that the operating system hasn't been updated yet, it might just say 1 var stats in your calculator. Then what you need to do in that case is press second 1, and that's the shortcut for list 1, and then press enter. If yours already says list colon L1, just go down to the calculate and press enter. So you'll see things like x bar equals 3.25, and that's the mean number of runs scored over the past 12 games for the Cardinals. And you'll notice there's like a summation x. That just means that all of those numbers added up is 39. And then you see some other kind of weird symbols that we'll talk about eventually. At the bottom, you'll see n equals 12, and because we have 12 numbers. And you'll notice that little arrow that's right next to the n. It's pointing down. Well, what you're going to want to do is press the down arrow and keep pressing it, because then you'll see min x is 0, which we knew, and q1 is 1. So go ahead up here in your notes, put q1 is 1. MED is median, or the M, and that's 2.5. And Q3 is 3.5. And we knew that our max was 11. So there's our 5-number summary that we're going to need to make our box plot. Now, all you need to do is I would just press clear at this point, go back to stat, over to calc, do one variable stats again, but this time do list 2. So you're going to need to press second and just 2, and that's the shortcut for L2. Then press enter or go down to calculate. And again, you'll see those same kind of weird symbols in there, but scroll down until you see the min, Q1, median, Q3 max. So I get Q1 is 1, which was the same as the Cardinals. Median is 2, so it's a little bit lower than the Cardinals. And Q3 is 6, which is much higher than the Cardinals in this case. Okay? Now that we've got those numbers, now what we're going to need to do is, do we have any outliers? Okay? So here's what I need to do real quick. I'm going to take a quick picture of this just so I've got my numbers and we can use them on the next page. Okay, so there are my numbers there. All right, so we're going to have to do that outlier rule twice now, right? We had to do it once for the Cardinals and once for the Yankees. So I'm going to do the Cardinals here in red. So my first I need to find my IQR, right? So Q3 minus Q1. Q3 is 3.5, Q1 is 1, so my IQR is 2.5. And now I need to multiply that by my 1.5. That was part of my rule. So 2.5 times 1.5 makes 3.75. That's how far above and below I can go the first and third quartiles to see if I have any outliers. All right, so now let's jump to the Yankees. I'll do the Yankees in purple here. The Yankees IQR will be Q3 minus Q1, but theirs is going to be 6 minus 1, which is 5, times, let's do that in green like I did for the Cardinals up there, 1.5, and that's going to give me 7.5. So I have a much larger IQR here. The middle 50% of my runs scored for the Yankees is much larger. It's pretty much, what, twice the size as the Cardinals. Okay, so the Yankees have much more variation. The Cardinals are more consistent in the number of runs scored in the past 12 games. So now let's take these numbers here. Good, that's all connected. So now when we jump back for the Cardinals, this time I'll go a little pink here. So if we go Q1 minus our 1.5 IQR, Q1 was 1 minus our 1.5 IQR was 3.75. So do we have any values that are less than negative 2.75? So we say there's no lower outliers. Cool. Now we jump up and go Q3 plus 1.5 IQRs. And let's see where that puts us. So Q3 was 3.5. We're now going to add 3.75. And we are going to be at what? 7.25? Do we have any runs scored that were greater than 7.25? And we did. We had the 9 and we had the 11, if you remember. So there are actually 2 outliers. The Cardinals scored way more runs than they typically have done in the past 12 games, in those 2 games alone. Okay, so now let's check our Yankee data here. So let's do brown. So Q1 minus 1.5 IQR. Q1 was 1 minus 7.5. Now we get negative 6.5, so we'll again say there's no lower outliers. Cool. Q3 plus 1.5 IQRs. We're going to be at 6 plus 7.5, which is 13.5. Did the Yankees score any runs that were more than 13.5 or really 14 or more runs in any game the past 11 games? No, they didn't. So there are no upper outliers either. Okay, so now let's take this. We're going to still use this, shrink it up, and let's see, where can we put it? I'll really shrink it up. We'll stick it right there. Perfect. Okay, so now for our box plots. Let's make our cardinal one here. So the minimum, which was at 0, so let's put 0 right here. And how do we want to do our runs? Do we want to do, how many, oh, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we can do this. We'll just add an extra line here. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And box plots can go horizontal or vertical. It really doesn't matter. Typically, they go horizontal more than vertical. But again, it really doesn't matter. So the minimum was at 0. So we'll put a little dot right here at 0. First, I'm going to take my 5-number summary and put dots for each one of these numbers. And then we'll start connecting and making the box. All right, so then Q1 was at 1. All right. Median was at 2.5. There's roughly 2.5. Q3 was at 3.5. And our max was at 11. Now, here's Q3, or Q1 and Q3. Here's where we make the box. And we put a line right where the median was. Now, the 0 down here wasn't an outlier, so we get to connect it to Q1. There is truly our min. Now, for the other end, I'm not going to connect Q3 to the 11, the max, because 11 was an outlier. I need to show that. And 9 was an outlier. So I need to come up here and put a dot at 9. And I don't, again, connect the 9 to Q3. I need to know what was the next number less than 9. And I'm going to have to jump back and look at my data. So the next number less than 9 was 4. So now I get to go all the way up here to 4, and then that's what I connect with Q3. These two little guys out here, and you can make those just dots, you can make them asterisks, whatever you want to, but they don't need to be connected to the actual box plot. Now, if I was properly labeling here, I'd have to put that this belongs to the Cardinals, and then when I come to the Yankees, I got their label here. Okay, so their numbers were 0, and 1, and 2, and 3.5, and, no, not 3.5, using the cardinal data there. Where are we at? 6, and 7. Now, since I had no outliers here, I don't have to worry about finding, the smallest or largest value that's not an outlier. So here's what the Yankees box plot looks like. Okay, and if I were to compare these two, and there's one more thing I might want to put in here, we'll say runs scored. That's what these numbers represent. If we look, the Yankees distribution is a lot more spread out. If we ignore the outliers up here, essentially for the Cardinals, we see that their centers are about the same. The interquartile range we said earlier for the Yankees is much more spread out. It's twice the width. So that we can see that the Yankees are a little bit more variable in how much and how many runs they score in games. The Cardinals are pretty consistent, except sometimes they have some breakout games and they really score some runs. Probably depends on who they're playing. Okay. Standard deviation now. Talk about some spread here. All right. The 5-number summary, we used IQR kind of to represent our spread. But standard deviation is going to go more with mean than it will be for median. Now, the definition, if you will, or description of a standard deviation, it's the average amount that the observations that are data, that are individual data points, are away from the mean. We're going to use a symbol of a lowercase s here, and you might think about it when you did one variable statistics. You probably saw an S with a little X after it. That is the standard deviation. But before we can really calculate S, the standard deviation, we need to calculate what's called the variance, which is really just the standard deviation squared. Here is the lovely formula. And I've kind of written little notes in here about what all these little things mean. Are you going to need to know this formula? Are you going to ever have to use this formula? No. Don't freak out. But that's the formula if you really want to write it out. Okay? It's really saying we need to take the mean, we subtract away the mean from all of our values, we square all of those things, we add them all up, and then we divide by, instead of the total number of values, we take the total number of values minus 1, and then we take the square root of all of that. And it seems like we're doing way much more math than we maybe really need to, but we'll talk about other things. So just a quick example here. Let's say I've got 5 values, 5 test scores. I have a person that scored at 20%, 80%, 85, 92, and 97%, and we want to find the standard deviation. Okay? You will never have to do this, but again, I want to give you a little bit of insight on what it means to be the standard deviation. Now, we mentioned before that the standard deviation is the average amount that our values here, our 5 values, deviate from the mean. So we need to know what the mean is. Now, again, I'm going to do a lot of these numbers for you here, okay? The mean is 74.8 of these 5 values. Now, if I take each one of my observations, which are little x sub i's, and I subtract away the mean of 74.8, I end up with these values. Okay, this is how far away each one of these values deviates away from the mean. Okay, some of them are negative, some of them are positive. Now, I'm going to take all those values now and square them. Oh, maybe I really didn't need that. Interesting. Wow, ain't that fancy? Ooh, fancy. I don't know where that went to. Okay. So if I square all these numbers, all my negatives now turn into positives, and all my positives still are positive. And then if I add up all these guys, here's that total I get. So now I want to take the total, divide the total, which is this huge number now, by n minus 1. And I have 5 values, so n minus 1's the 4. So I get 980.7, and that is approximately, or that is our s squared value, okay? So now I need to take the square root to get rid of the square to get just s, my standard deviation, and that is 31.32, which is my standard deviation. So on average, values, or my observations, my test scores, deviate by 31 percent points away from the mean. Okay, again, let me say that. The average amount that my test scores deviate from the mean of 74.8 is 31.32%. And you're thinking, man, that seems like a big percent to deviate from, to have that much spread. Well, it is. But what's the main reason why that standard deviation is so large? Well, it's that outlier score of 20. Look at how much of the 3922 that 20 contributed to it. 3,000 of it. That's why we get such a huge number here. Now, if we want to know the average deviation about the mean, why didn't we just take the average of that second column? Why don't we just take the average of these numbers if we want to know the average amount that scores deviate from, right? But if you add up all these numbers, something peculiar happens. It always adds to 0. Okay, so the average would always be 0, and there's deviation, but the deviation can't be 0. So that's why we square everything, to make everything positive. And then towards the end, since we squared all this stuff, we have to undo that squaring process, and that's why we square root. Okay? There are other different ways to do a standard deviation. There's something called the absolute value deviation, or the mean absolute value deviation. I can't remember exactly. I think that's what it's called, the MAD or the MAVD. But it's something we don't really discuss a whole lot. We primarily stick to this standard deviation. So some properties. S, our standard deviation, it measures spread about the mean and should only be used when the mean is used to describe the center. So if you are using the median to describe the center, you're not going to want to use standard deviation. Okay? It's not peanut butter and jelly. It's like saying, I want peanut butter and cheese. I don't know if anybody eats peanut butter and cheese sandwiches, but that's kind of weird. But hey, if that's your thing, cool. The standard deviation will be 0 when there's no deviation, when there is no spread. And this only happens when all the observations have the same value. Okay? So, if we went back to our restaurant scenario from the last video and we said you've got your 4 employees that make $5.50 an hour, there's no deviating because the mean is $5.50 and each of your values is $5.50. So the average amount of deviation away from the mean is 0. Okay? Otherwise, your standard deviation will be positive. So it's either going to be greater than or less than to 0, essentially. And the observations become more spread out about the mean. S gets larger. So if you have larger and larger values, your standard deviation is going to get bigger and bigger and bigger. And the standard deviation, like the mean, x bar, is strongly influenced by outliers, meaning it is not resistant to the effect of outliers. And last but not least, can you use your calculator to do standard deviation? Absolutely. That's the only way we're going to do it. You'll never have to do it by hand. Now, the last thing here, and I kind of mentioned this before, if you're going to use mean to describe the center of a distribution, please use standard deviation. Okay? This is peanut butter and jelly going together here. Mean, standard deviation. If you're going to use median, use IQR, use interquartile range. Don't use range, maybe. I would stick with interquartile range. I know it's a little bit more work, but again, your calculator can do all that for you. Okay, so median, interquartile range. There's what's something else that goes together? Um, ham and cheese. Sure, I don't know. So peanut butter jelly, ham and cheese, those are things that go together. So again, the IQR and median work better than mean and standard deviation in skewed distributions. If something is symmetric looking, approximately normal, definitely go with mean and standard deviation. And our numerical summaries do not fully describe the shape of your distribution. Remember I said if the mean is greater than the median, then that might mean, I didn't say it will guarantee that the shape is skewed right. You're not guaranteed that, which is why it's always important. And I know some certain teachers, maybe in the physics department, from what I've heard that he's told many people in physics, to always plot your data to get a good idea for what it truly looks like. Don't just use the center and spread to get an idea for the shape of the distribution. And that is all for the first chapter. I hope you had fun. And we will now review and work a little bit more before the test. Adios and goodbye.